Second. Okay, today we have 6th lecture, medical mathematics and biostatistics part of course. Topic of today's lecture contain pairs, and I will start with development of relational databases, which is, I consider, extremely important to at least understanding this principle, because those explain why real application work in specific way and not in others. So first of all, we have to I will provide some introduction about what is databases, and then few steps about development of relational database, and finally some notices on NoSQL databases, and so on. Okay, as of about first question of lecture, we have to define what is a database, what type of models used for database development, and so on. Before it would be fine to remember and repeat what is information system, because it's keystone to be introduced to databases. So a system person that acts activities that process data and information given organization, including manual process, automated process. And computer-based information system is information technology component of real information system, and their objective goal of studies field studied for information technologies as scientific area. So in fact, any practical software applications that work in medical facility have to be considered information system, and actually each of this application made up on top of various database. Just for review, here is we can see here is for major aim of any hospital information system is to achieve the best possible support of patient care by administration of bioelectronic data processing. And here is at right side, you see various type of hospital information system, no matter if they are like independent, integrated, or standalone. So all this information system are typically made of on top of various databases. So, sorry, they use database to store those data that they are dedicated to, and they use specific classes of database management system to manage that data. So today, right now, I will try to introduce both. And if we consider like structures, schemes of some medical information system, here is we can see elements which depict place of databases within information system, and it could be even sometimes more than one, like in given case when specific integrated information support system use at least 3 database to provide some outcome. Or another practical solution, which is like advertising of PACS solution, PACS and DCOM solution. So here is also, you can see here also mentioned at least 2 database, which is used in this practical system. So in fact, if I would continue to present such workflow and diagrams, it will be more and more icons which labels which represent databases, because again, almost entirely our information system, medical information system, not only medical, our information system right now use databases to manage data. So here is we come to a point to define what is a database. Here is a pair of possible definition available, much more. You can present your own, just maybe I might ask about clarification in necessary. So we can consider the base as computerized record-keeping system in brief, but in more details, it's a system. It's also information system which involve data, hardware, including networking sets, physically stored data, and software that utilize hardware resource in order to store data and provide standardized method for retrieval and changing the data, and users who turn data into information. No, actually, users do it through third-party software, but such as again, those information systems, third-party software dedicated to manage data. So here is we can bring users on database definition level. And so actually how it's look like from user perspective. Usually professionals have seen only that left side at their devices, computers, laptops, phones, etc., which represent user interface of information system. But behind this user interface, available some client app with kind of business logic, which access data storage, in this case, given example for SQL database, but at the bottom, right at the bottom could be even considered non-SQL database. So they those clients app use data storage, or actually usually not directly, but through intermediate software, very important software class called database management system, DBMS, which is responsible exactly to provide some approach to physically access data, physically store it, and some serve data for users in some standardized way. Okay, now about classification of database, few words. In general, two large group, analytical and operational database, could be distinguished. Analytical, it's a static read-only, which store various archive, historical data used for analysis. Operational database used to manage more dynamic bits of data. Database allows you to modify data, add, change, delete, actually perform so-called CRUD operation. This test database usually uses to track real-time information. In fact, this separation not strict, because very often in modern databases same database could serve as operational and analytic at the time, just owned by administrator. About administrative stuff, it's defined the rules and permissions that since a specific point in time, the values they can't be changed anymore, and they become part of archive subsystem. So again, it's actually more logical separation rather than technical or physical. What is more important, it's database model. So again, still a logical approach to organize internal structure of database, to represent internal structure of database. And here is we have at least 5 of it, 5 basic listed here, but we can a little bit extended right now. So simplest way, usage of flat files, which is actually very deprecated, very old ways. It's few files like CSV, spreadsheet. Yes, they could act as database in logical manner in specific circumstances. But despite of that it's deprecated, it still sometimes had been used for like at least manage personal data, which is actually not bad. More general types is hierarchical, which represent tree-like structure, and network, which is based on set theory and provide like extend tree-like hierarchy with multiply parents for each one, possibility to have multiply parents for any specific children level, so which have multiply interconnection. Relational database, one of the most commonly used today, despite all efforts to like share and provide some and extend usage of NoSQL database, still major part of real information system use relational database, which are based on two-dimensional tables similar to spreadsheet, but apply more strict logical limitation on how data had to be arranged and used. And actually post-relational or object-oriented database, which is completely based on relational model, but provide one more level of flexibility because manage attributes and its values separately. It could be seen in form of the following chart, when we can see a flat file model at left top side, the hierarchical at right top, network right bottom. So here is given this point, and relational a little bit hidden behind, and object-oriented right left bottom given here. So here is give for you some at least basic insight about what do we have here. So a few more words about some of these models. So hierarchy of the base, as it's obvious from its definition, from its name, from its title, can be visualized, type of relation can be visualized as upside down tree of data. Single table acts as root of database from which all the tables branch out. So major problem of usage such models is that can't be added to achieved until have been already incorporated into parents table. So prob had been created full hierarchy before. And redundancy, because hierarchical database handle a one-to-many relationship well, but not handle many-to-many relationship. So in this case, you have to add or duplicate instance of the same object, or even full half of tree, or looking for other way, but it's actually there are no of this. So here is we have at the bottom given case how we want to add the same person to be assigned to department, to additional position, partial position or so, or like students try to get second education at a time. So here is we have immediately got this problem with duplication. Network model. Here is already spoken that instead of a single parent tree model, use set theory and provide tree-like hierarchy with that few labels allow it to have more than one parents. So as a result, it's extremely good to support many-to-many relationship, but it's actually difficult to implement, maintain such database. So it's only a practical solution available for only very specific enterprise companies, application, etc. But anyway, we can achieve situation like this one, when more than one parents are allowed for the same child. Not so extremely effective approach, but very difficult to maintain. An intermediate solution which become in this reason extremely useful and comfortable and still dominate market despite being introduced about 50 years ago. So data represented in two-dimensional table, but we have strict limitation. Each table represents information about specific entity, real-world person, place, things, or non-material object like events. So we collect information about this entity only under this specific table. And we can also link tables by using relationship. And here is second key difference from, for example, spreadsheet. Because table in spreadsheet not enforced to be used entities, you are limited only with cell capacity. And also spreadsheet, you can make link between cells in relationship between tables only. So later I will talk a little bit more about relational database, but in fact it could be look like this one, and here is how we can define table and how we can define a relationship. Later will be a little bit more about this. So now move exactly into development of relational database, because those reasons they still dominate market and still very useful. So some steps notation will be presented. Then after I provide some basic of relationship models, so we'll need to provide some more details, that data structures, terminologies, major properties of relational tables, usage of relationship and keys, no, even up to normalization. I will try to get few words on these points, and DBMS as practical approach to implement tables. So in fact, development of an information system passed through specific steps. And here is we have the same things with databases. So first of all, it's for sure requirements analysis with some planning steps and definition of our demands, then creating design, which first of all we identify logical models, which is at first place. It's identify logical model of our data, of its hierarchy relationship, and so on. Then possible to make some assumption about physical modeling by using specific database management system, and then implementation with that particular DBMS and testing and going into production. Or another approach for the same step, when we have collect data from problem domain from data modeling, design, implementing, and run into production. So all this three pictures spoken about the same things. Actually, what is results of database design? It has to be something like, it's one of the possible representation of design, a so-called entity relationship diagram. In this case, it's especially for hospital management system when we have in blue boxes some entities, which is their relationship represented in green rhombs, and for some entities even provided details with that's ellipses. In fact, it's even not complete hierarchy. You see some parts like they are closed with double lines around entity, and here is we have some logical condition, red triangles which dedicated to choose a specific entity under specific circumstances. So in reality, it's very difficult to depict R diagram for really a complex practical system, but at least this one approach we have. And it's good design, at least make logical view in this form. It's give for us understanding about which entities we deal and how they have to be connected one to another. So it's good starting point. And here is important to understand that this organizational data and relational table is known as logical view of database. So it's form in which relational table present data to user and programmer. How it's practically implemented on physical level, it's for this responsible DBMS system. It's actually not a real concern for user. So we have logical view, which is presented like two-dimensional table. And actually idea of relational models. So despite implementation could be different and physical model could be different for each DBMS, our DBMS must present users in uniform logical representation of data. So they could be then interchangeable and possible to establish some integration between data. And here is a usage of term. So in addition to usually when we talk about rows and column in table, we have formal topics, formal terms for relational algebra. It's middle column, which is spoken about relation, attribute, and tuple. Sorry, maybe not visible, but last row at the bottom is a tuple. And they represent table, column, and row respectively. When database manuals and various even software manuals spoken about table, fields, and records respectively, when we're talking about tables, columns, and rows. So actually, I encourage you to use or middle or right terminology when we're talking about database. Personally, I will follow last one, right column. Like when I will talk about database, I will talk about tables, fields, and records. So this one is comfortable for me. So here is mean again, column, it's the same as field, and row, it's the same as record. So as consequence of this, as outcome, relational table is collection of relational database collection of relational tables. Relational table is the object, not only a flat file composed by a set of named columns. So here is points, columns must be labeled, columns or fields, and arbitrary number of unnamed rows or records. The data value is stored in the intersection of row and column. It's like a same as spreadsheet. Columns contain information about object, entity, attributes, and what is important, on each one specific column must contain information about only specific attribute. So if column dedicated to store like first name, it must be used only for first name. It's dedicated for email, only email, and so on. Same way, row records represent occurrence of things represented by the table. So it's object entities or objects entities instance. Entities instance or object instance. Possible to use both term. Or it's also called records. In fact, it's information about one particular thing. For example, if it's patient database, it's information about single one patient or single one students or so on. Okay, major properties, atomic value, column variables must be same kind, each row has to be unique, sequence of columns is insignificant, sequence of row is insignificant, and column must have unique name. So it's almost spoken, at least part of this. Value atomic columns in the relation table are not a repeating group of arrays. Such tables refer to main using the first normal form. To be honest, in a recent version of relational databases, it's kind of a little bit omitted, and it's possible to store a series set of data inside one cell of relational table, for example, some object or something like that. It's not like very, cannot consider it as very correct, but it's used relatively, it has relatively wide usage right now. Columns values at the same kind. I already noted about this. If it's dedicated to store email, it must be used only for this. If it's dedicated to store, for example, good price, it must be used for store good price, and so on. In relational terms, this means that all values in column come from the same domain. It's not internet domain. Here is we means domain of values. And the main set of values which column might have. So it's like domain of email names, domain of unit prices, etc. And here is strict limitation. Your database will not working properly if you try to break it out. Each row unique property ensures that there is no two rows in the relational table are identical. There at least one column, at least one value must be different, and it must be used to uniquely identify each row in table. So we must have kind of attribute, kind of field or column, which will be ensure that it's with 100% guarantee provide unique value and which allow to separate records in table. It might have situation when user type data twice, like forget and try to input patient data or student data twice. So system must be able to distinguish these records, and here is provided by this unique field. Sequence of columns and rows is insignificant. Here is also important. We concentrated data, no matter how we arrange it, in which order, what you will place first, email or last name. So it's no matter. And also same about records, about patient, no matter which order they will be, we have to be able to separate it by different criteria or so. Column has unique name. Okay, it's already also obvious, and provide the spoken that's impossible to have the same names for columns. And here is time to introduce relationship. Relationship in relational table is association between two and more tables. Please don't mix these things, relation and relationship, because in relational database, relation, it means table itself. In relational algebra, in relational database theory, relation means table. There is a relationship, it's association between two or more tables, and expressed in data values on primary and foreign keys. So here is also critical point. When we draw R diagram, we express relationship with line. Also, when you will use a visual tool to manage relationship in database, it's also drawn by lines, but it's only made for users' comfort, for developers' comfort. On the database management system level, relationship expressed in data value primary and foreign keys or key fields. So only database core match value which is available in the designated fields, which are designated to be case, and based on they are match or not match, its database core will manage with data. So primary keys, it's exactly column in table whose value uniquely identify each row in table. Oh, sorry, mistake in Ukrainian. Here we have no problem. In fact, here we're talking about those questions that how to implement that demand of relational models, that each row must be unique. It could be done through introduction primary key. So we provide usually additional synthetic key, which is not belong to data itself, and which will fill it with unique value. Usually it's made of by the database management system itself. To be honest, sometimes possible to make the primary key by existing data, but it's very complex and not very often happens. So to be simple, I consider for you that will be not mistake if you add the extra key for each your attribute, and it will be 100% warranty that you does not have any problem with duplication or data or some doubts about distinguish records. Okay, foreign keys, column or columns, those values same as the primary key of another table, and the relationship made between two relations by matching value of foreign key in one table with values of primary key in another. And it will be this way we will implement a common relationship type like one-to-one, one-to-many, and so on. Well, actually, only this pair. Later I explain why. So again, here is so with foreign key, it's usually additional synthetic attribute, but this time it's linked to its value, its value domain, linked to the same from particular primary key. Values in foreign key can't be in other than in related to it primary key domain. And the only difference, value in foreign key could repeat multiple times. Primary key value can't repeat, but foreign can. Okay, so here is example like we can do, we can add the primary key to our existing database, which is about maybe some stuff, information about stuff of any company. So here is added like ID, which is used only inside the database. Please don't mix with some kind of personal ID, passport or so. No. And usually it's not a good idea to use passport or any kind of other similar identification as primary key. It's not a good idea because we have mobility of people around the world right now, and even we have people without passports sometimes, or with various issues with ID or so. So in system, it's very practical to introduce own system key for each table. And here is how foreign key will work if a person belongs to specific department, and each department have its own primary key value. Here is called department code. So to express this belonging, we will use this value of the corresponding value of department code and assign to each specific person, which has his own primary key, like as you see this case, teacher ID acts as primary key for teacher table, department code acts as primary key for department table, and here is we repeat department code, even could be field name different on the teacher's table. So here is we got we able to introduce relationship, and we have a foreign key into teacher's table. So in this case, teacher table has two keys, primary and foreign at a time. So it's actually multiply keys necessary to implement some kind of relationship. In simple case, we have like, in general, we have three types of relationship: one-to-one, one-to-many, and many-to-many. One-to-one simple case, one instance of entity A associated with instance of entity B. So in this case, a relationship could be even established by using primary key value. So, for example, in this case, we can repeat products ID, and if you want to like provide some extensive details on some entity, which is required more rarely than major information, we can split this and into second table and use it, access it by one-to-one relationship only if it's necessary. Here is we have this implementation. Practically more often, and like 90, maybe 98% in practical database, we met implementation of one-to-many relationship. Here is, as I note, in real in practical relational database, we met one-to-many relationship in 98% or maybe 99%, and remain one, it's one-to-one only. So in this case, one-to-many relationship, when for one instance entity A could be 0, 1, or many instances of entity B, but for instance of entity B is the only instance of entity A. So here is we have assigned projects to department, teachers to educational department in universities, students to by specialities, and they studied, and so on. And here is we can continue with its thousands and thousands of examples could be seen here. Or for example, teachers to classes, like right now I am assigned to this lecturer, but have also more classes today. So that in this case, for me in the SU management system for today, at least three classes records are available, one for this lecturer and next pair for practices. In this case, we need two tables with like master table, which contain primary key only, and some detail tables. This, in this example, is teacher. Sorry. master table is teacher in this case. Have only primary key. Classes table, information about classes, it's detail table. It's also have primary key class ID. And such as we must know which teacher will serve this class during this particular class, during this day of week, this time. So we have to add teacher ID, and it will be act as a foreign key. And in this case, we will be able at classes side store and multiply records about all teachers' classes. And here is for each one teacher, we will have one-to-many relationship. For one teacher, possible to register multiply classes. He has been assigned to. Okay. And many-to-many relationship, one instance of entity A is 0, 1 of, or many instances of entity B, and for instance of entity B, we have also 0, 1 or many instances of entity A. So, and here is situation in contrast to previous, and here is situation in reality. When you just start to analyze subject domain in order to create database, first you will find it will be definitely many-to-many relationship. But to implement it practically, there is no other choice than split it into multiply one-to-many relationship. And here is we have like multiply let's consider education in university, and we have multiply students, multiply classes which provided by university. And to ensure which student had to be assigned to the specific class, so there is no other approach than use at least pair one-to-many relationship when, such as each class is unique, each student is unique, and we use intermediate enrollment table, which will contain multiply foreign keys. So it could be even only considered with key fields, like each one enrollment definitely is unique, and it's in, as you can see, enrollment ID, you will have this extra primary key, but also there are available two foreign key which students in classes which provide which provide for us relationship between to which student to which class enrolled in. And usually in this case possible to be given like times enrollments, like start enrollment, ending enrollment, and so on. So here is what do we have when we talk about when in reality we find place for many-to-many relationship. We have to think logically how to split this many-to-many into one-to-many, and how much one-to-many relationship do we need really in this case, because here is shown very simple case. Let's show another example from like trading companies this time, not university, when they sell some products, and same products could be involved in multiply orders, so they also have to use order details intermediate table, which so orders and products joined with many-to-many, and orders with details, or details and products with details joined with one-to-many each. And here is again we have pair of foreign keys, and also we have to add some order details, primary key, and so on. Again, this pair of example very simple. It might happen that it will need more intermediate table to implement relationship between particular entities in relational database. And if you even try to think about enrollments, student to classes. So if you will involve student speciality, groups, years of study, so you will see much more levels of details have to be provided, and much more keys and one-to-many relationship will be required. So in reality, those it's much more complex structures represented, but just to visualization, as for me, it's look like a little bit enough. Here is help. So when we talk about real life many-to-many relationship, you have to remember that it must be split into at least 2 or more one-to-many relationship. Okay, so here is explanation about text about that things I already spoken about previous table. It's major things which is required to create to start creating of design of relational database. It's understanding of concept of relational table, keys, relational table, fields, records, primary foreign keys, relationship type one-to-one, one-to-many, and how to implement many-to-many to pair or more one-to-many. Once you will be like at least basically aware of it, you will be able to work with design database, at least try. So we have much more topic under relations-based development, which is also significantly important. For example, like this one, data integrity. Means that you can correctly and consistently navigate and manipulate database, and entity integrity and referential integrity. Entity integrity rule states that value of primary key can never be null value and should never be unknown. Or actually can't be even more, can't be repeated if it was used once. And even if record being deleted, it must not be used again, and so on. So referential integrity states that if relational table has foreign keys, every value of foreign key must either be null or match the value from in the relational table in which the foreign key is a primary key. So it must be not something like omitted or lost records when we remove, like for example, patient record and some observation, examination retains, or we remove a student's record from database and some his grades or enrollments have to be removed again. Actually, it's violate approach when we should have some history of enrollments. So for sure, it's but it's a little bit another question. So depending to policy, if that means we can preserve records for some time, but it's already, for example, past 50 years or so, they could be deleted. In this case, we can even delete analytical part of data. And here is time to at least give for you essence of normalization, because as I already said, when you will try to start to check real subject domain, you will find that number of entities very large. And you will try to evaluate your own task about database design, you will see that it can be find a lot of entities even on the task which is sound like simple. And as a result, it's led to possibilities to create very different types of R diagrams. So actually goal of normalization is to create set of relational tables that are free of redundant data and that can be consistently and correctly modified. That's actually separated area for study under general relational database studies, which is in fact subset of algebra logic scientific area. So that's we talk about kind of science as well. And normalization theory based on concept of normal forms. 5 designated by theory, practically usually up to 3. And normalization essentially is steps process that puts data into tabular by removing repetition group and then removes duplicated data from a relational table and repeat it a few times until we accept proper results. So here is we have like unnormalized table above and joined everything. Student, advisor, its room, classes, etc. When we just bring it to normalized form, we eliminate the repeating group, which is class, and use class ID. Here it will be, instead of class 1, 2, 3, we use single one class ID, and we can organize data in the following way, but this time we will have like repeated information about students, and advisor. Here is we have unique columns. We doesn't have this class 1, 2, 3. We have our unique columns which represent some same attribute, but we have redundancy in data itself. In second normal form, it's fast and every non-key column fully dependent upon the primary key. So in this particular case, we have to split one table in two and separate student, this time with advisor, from like classes. So because previous time you see that we have repeated information about students and advisor, and we have every class was unique. So if we just assign some primary key to each student and we'll repeat it for each class, we will have relationship one-to-many between students and class assignments here. And the third normal form, so by the second normal form, and every non-key column and non-constant depend upon its primary key. In other words, our non-key attributes are functionally depend only upon primary key. So definition is complicated, and it really is complicated, but practically it could be seen very a little bit simple. First table, not second. Table 4 we don't touch. Table 3 we will separate in pair. We split this time students and their advisors. So here is we have now only information about which advisor assigned to particular students by again usage of this for primary key. And in this case, it's look like at least at this point, it's look like for this data, it's look like one-to-one relationship. But once we added the more students, and the two students still could be added to be advised by the same person, so we will got one-to-many relationship again. Okay, and finally, we can depict this in the following type of R diagram, which is slightly different than previous notation, but exactly depict information from previous time. How we can use faculty students registration for this particular case. At this point is time to introduce DBMS. I have already a few times spoken about DBMS, which is a special class of software that control creation, maintenance, and usage of database. It's a low organization to develop database various application by using by database administrators and other professional specialists. So with the database management system, it's possible to manage data structures on the database, create update necessary data structures, objects, relationship between them, and provide standardized API to access by database application. And here is how it could be look like. Above picture I have already seen before. When user work with database application, like with various using various visual objects, and a database application makes standardized cloud database management system, and database management system responsible to how to store data on physical layer, and again provide the standardized response for users. More general case, it's be not only one user but multiply user definitely as a database Some intermediate or integrational application could make calls to RDBMS, and RDBMS provide standardized access to some storage area, and even might happen that one RDBMS could serve data, different type of data from relational as well as non-relational components of database. That's I'm talking about a very enterprise level, but here it is. And here is example how it could look like visually. So here is we have MySQL DBMS, and especially its visual tool with R diagram open. So here is R diagram from live database. And the administrator can review it or use other tools like listed at left side to manage tables, data here, and so on. So what is actually used for, what is key points and key tools inside database management system is, especially if you're talking about relational database, is SQL. Or structured query language, standard language for storing, manipulation, and retrieve data in database. So if you talk about relational database, we almost every time talking about SQL database, and means if you properly create, if you will use standardized call it ANSI syntaxes of SQL query, it will work for any database management system which serves the same data, no matter about what manufacturer of this DBMS is. And you will be able, for example, to execute this query, for example, to not only select, but create data, create structure, and so on. So it means with standardized code, so ANSI SQL, you can move your database structure within different platforms, within different database management systems, and get the same things. And here is how it's look like. At left side, we have sentence in SQL, which is dedicated to select some, at left side, commands of a SQL language. At right side is argument, which provide, for example, select which exact fields have to be used from where area define condition, and there we have groups and orders criteria how to manage data. You will have such classes. Practically, SQL very closely joined to the truth table, which is again check formal logic theoretical topic. And here is given a type if you want to combine two sets in different cases like unification, intersection, etc. Here is we have at right side R diagram, an example of truth table at left side. And actually, again, that's SQL itself reflected even up to relational algebra theory, because here is we have no other thing that's intersection of two sets. So we can do it with SQL, select only those records which are available in both tables. And here is will be this A1, B1. So here is, and how we can, it could be depicted into relational algebra. Okay. Practically, you will not working with SQL in this during your practical classes because lack of time, unfortunately. So you will work only with Visual Tool, but just keep in mind anything you do with database with Visual Tool actually being converted to SQL and execute by database core, and you will get result on the that. And now time, quick introduction into NoSQL databases. So what is understanding? What is this types relation? Now compare relational based NoSQL database and usage it in medical application. Okay, stands not only SQL or not SQL, proposed at the end of 20th century, reintroduced in 2008. Non-relational database management system does not require fixed schema, avoid joins, and easy to be scaled. Okay, discutable, but possible. Use it for distributed data storage with managed data storage needs. So in fact, really all big data companies like Twitter, Facebook, Google, and ESA, so they have terabytes data, and for them usage, even distributed RDBMS, it's actually impractical. So they usually use NoSQL databases, at least at top-level hierarchy. At local storages, they still rely on multiply relational database, but to aggregate all the storages, they use a NoSQL database. So here is we have SQL, as I already mentioned, we have like relational analytical database. NoSQL we can consider graph. Here is, as you can see, graph and documents database. That's actually implementation of hierarchical and network model. This pair graph and document database. And here is place where NoSQL database act better than relational database to maintain those such structures. Here is we have this. Okay, how it could be look like? Key value database. So we have some pair of, again, it's very, implementation will be very similar to relational database. We have just table which contain key and value columns and proper we can input any kind of keys and any kind of value. So again, at this point, as for me, it's even not clearly to be covered NoSQL database, because this kind of NoSQL database actually almost exactly the same like object-oriented database. So this table could be implemented under, this approach could be implemented under relational database. And the only question, if we will try to use SQL to extract value for specific key, for example, get our names, that will be led to very complex condition, because we doesn't have column name. We have, in terms of relational database, we have value name. So, but it's possible. Okay, other solution, most practically used solution is document-based NoSQL database, MongoDB, CouchDB, and others. So they dedicated to store some set of documents with and provide index to quick access of those documents. Practically most useful in field of NoSQL database. Column-based, okay, we have solution like Cassandra, Hypertable, and so on. Actually, means under one column, it must be multiply case and multiply value. Here is difference to relational database. Actually, also could be implemented on top of relational, but violate relational requirements. And graph-based. So here is we use graph theory to implement entities and relationship between them. Okay, document-oriented NoSQL stores and retail data as key value pair, but the value part stored as document. Document storage, so in XML format, value is understood by the DB and can be queried. So here is we have these things like at left side relational part of document-oriented database, and at right side it's like actually document which corresponded to each of these 3 rows. So they are ended up with some document, and they are stored separately and referred by links, those documents. And so here is key points. Value and understood by DB can be queried. So you can not only retrieve document as container. It's possible with relational database. No, you can make search and retrieve part of document by internal NoSQL database techniques. So that's work this way MongoDB works. Here is given example of MongoDB user MongoDB types of NoSQL document-oriented NoSQL databases, which is available and popularly used MongoDB. My small mistake, MongoDB mentioned twice. And here is given equivalence in terminology between SQL and NoSQL database. Like database, it's the same. Tables represented by collection, rows by documents, columns again, fields by fields. We will try to compare. So what is good and depict maybe a powerful and weakness position. So we can see that SQL better vertically scalable, NoSQL better horizontally scalable. SQL have fixed predicted scheme that's much easier to create queries and retrieve data. NoSQL have dynamic scheme which give extra flexibility, but unfortunately it's very difficult to create queries there. As I already mentioned, SQL not suitable for hierarchical data storage, and that it's area where is NoSQL database work extremely well. In compare with SQL, we can create very complex query, extremely complex query, and not for NoSQL databases. Okay, as a result, we have, in both cases, we have positive, negative points. We have pros and cons, which is shown on this case. Major, so SQL as already easy to use, have fine predict tables, have structured data, but difficult to scale and usually difficult to provide reverse engineering. So if you have an existing system and want to create custom query, you need to evaluate structure, which could be very complex. Try Moodle or Open EMR, hundreds of tables, how to evaluate their relationships. In contrast, in the SQL database, we no need, in fact, almost design model, quick development cycle, very well adopted to various distributed clouds, but we have also disadvantage, which is considered for in interconnected data. Will be slower with large amount of data, etc. So we have also a number of limitations. Anyway, in practice, it will be usually become clever idea to use both and get best effects from both technologies. And here is given in a link. If you will access, I think it will be uploaded in Moodle, already uploaded. Then you can get access to this article, which show for you practical solution which combine both in one system, in one medical EHR database management, EHR medical information system dedicated to storing the medical records. Here is it's allowed to get benefits of both architectures and combine relational database to store some structured data and collect unstructured documents under MongoDB accessible. So here is like how it's combined. We have model in RDBMS and data model MongoDB, which still could be interconnected. Okay, that's all about actually development of relational database, introduction to development, and I get back a little bit to second part of lecture 5, which I have not yet provided, and which is again, I spoken about information systems those time, but right now and I have already introduced topics about electronic medical health records in those lectures. So time to little bit extend it and provide some more insights. So when we talk about medical records in general, for sure you already met it in your clinical subject, and you will met it multiple times, this topic. Actually, I will provide only a brief overview, medical records, purpose, format, concepts, etc. So when we talk about medical records, not about electronic in general medical records, that's thematic documentation, patient medical history and care, and use it both for physical storage, which filled with paper document. It's not changed for hundreds of years. And body of information, which is more important for us, like we are talking about informatics, that's body of information, and which comprise of total which patient health history. And that so information allow healthcare providers to provide continued care to individual patient, also serve as basics for planning patient care, documentation, communication between healthcare providers and any other health professional contributing to patient's care, assisting in protection and the legal interest of patient and healthcare providers responsible for patient care, documenting care and servicing. And also medical records serve as education medical students. Yes, it's for you, residential physician, to provide data for internal hospital auditing for quality assurance, and also so that's essential point, essential tool which we must be deal with, and contained medical records vary upon depending upon specific location, usually contain foreign patient data, identification, health history, medical examination findings, and any other information which can be useful, like various lab test result, prescribing, referrals orders to healthcare providers, educational materials, medical images, etc., etc., etc. So more we collect on patient, it's better to add everything into medical records and keep it updated every time. And medical encounter, actually it's medical records composed by medical encounter, which generally contain aspects like compliant, problem has brought to patient to see doctor, the history of the present illness, like daily expression of symptoms that patient experiencing with health, request patient to seek medical attention, physical examination, encoding of observation of patient during this medical encounter. So any vital sign, examination of different organ system, which might directly be responsible for symptoms the patient expecting, experiencing the then assessment and plan, some written summary, and what are the most likely caused the patient current set of symptoms, and patient one document expected cost to be continuous care provided. So then orders, written orders for biomedical providers are included, medical records, details including given members of the health care teams by primary care, test results, progress notice, information about like success in treatment, and so on. So that's we're talking about general medical records. And for sure, when we try to replace introduce usage, when physicians try to introduce usage electronic computers in the hospitals 40, 50 years ago, that's first idea where it would be possible to like turn medical records into digital format. It was not going immediately well. It's sometimes were necessary to accomplish this. But finally, we got success, and so major years on its get information instantly available on our demand, turn like sometimes miles of paper use into, or at least gets them accessible on demand and at a time. So as a result, it's our ability to access significant patient details, allow collaborative work on patient data, some provide visualization, insight, automatic analysis, and so on. And also give ability to various as not only medical staff but other hospital staff access to patient data to simultaneously create various billings, insurance report, and provide educational cases as well. So electronic medical records, actually, it's medical records in digital format. In health informatics, EMR are considered by some to be several types of EHR, electronic health records, but in general, EMR and EHR, it's synonyms. So again, I will also not blame you for this, but in general case, EMR slightly different from EHR. In terms that sometimes other, like health information technology system will keep track of medical information, such a practice management system which support electronic medical records. So that means sometimes under EMR, people means medical information system, which is okay. It could be used this way, but not exactly correct. And when we depict type of electronic medical records, so we have identified at least three. EMR in general, electronic health record information on individual within one healthcare organization. Here is key points. EHR, electronic health information on individual across more than one healthcare organization. So if you visit multiply medical providers, each one create EMR for you, and aggregation of this multiply EMR will form your EHR records. And if you are given access to these records or part of it, so those accessible for you part will form personal health records. The individual managed, shared and controlled by individuals. So when you not only have access, but have ability to provide access for this. So here is how it could be visualized in this case. When we have we visited provider, we got created EMR for this provider aggregation, if it's available in like particular country. Usually it's a state responsible problem to create some medical backbone and enforce providers to integrate into this network. And for example, in Ukraine, it's eHealth right now, which dedicated to some part of data you are allowed to manage by yourself, especially, for example, if you use various fitness device or personal examination device, which dedicated to collect some some vital signs, some medical information. So you have to make decision about sharing and managing it. Okay, electronic medical records might include, here is list of items. It's again actually could be less or more. In fact, it would be fine that EMR include as many information as possible, as much as possible, sorry. As much as possible, like its paper predecessor for sure. And here is definitely demographics, medical history, examination reports, allergy list, immunization status, any laboratory results, any medical images, photographics, etc., medication information, side effects, interaction, evidence-based recommendation, record, and supplementary information like billing records, appointment records, etc. So ideal characteristics of EHR information should be able to be continuously updated. Here is that's key point. There is no reason to introduce EHR if you will not be able to update it, if you will not be able to track patient changes and fill the data. Should be able to use anonymously for statistical reporting. No, it's not. It's like less critical. If you want to interact with other system, provide anonymous but statistical reporting. And ability to exchange records between different electronic health record system, interoperability. So that's, I already spoke in second lecture, repeated at fifth lecture about, also repeated about this. And again, I point on interoperability right now. So they're mostly state-related topic because state is responsible to enforce interoperability. In fact, interoperability is different information system software applications to communicate, exchange data correctly, effectively, and consistently, and this information has been exchanged. Here's information exchange organization in 2004, United States form of National Coordination for Health Organization Technology was created in order to address interoperability issues in established National Health Organization in network. So some similar organization in Ukraine had been created only in 2017, which then started with under our Ministry of Health, and they started to manage our e-health system. So 13 years delay. Okay, and second lecture, I already shown this chart, so no reason to repeat this. Just only spoken about levels of interoperability, like non-electronic, machine transportable, machine recognizable, machine interpretable data. So in fact, if we talk about exchange medical information, even level 3 is enough to establish interoperability. Actually, it's more legal question rather than technical, and the following chart expressed demand, legal demand, which was available. It's like already about 2 years old, or even, no, sorry, probably 3 years old, like per different countries, what kind of demand already provided to exchange data between information systems. Ukraine even not listed there at that time, unfortunately, despite we already had health at that time. And what is important point when we going from paper to digital, it's not important only to start recording and maintain current electronic medical records, but for those patients who still alive, it's would be fine to incorporate their previous older paper records, which is actually extremely difficult process. It's be even more difficult than implement usage of EMR system itself. So if you have question for scanning of thousands of documents, and if it's actually a question about some kind of recognition, because then sometimes very difficult to manage with content of this document, but still it's important question. It's have to be done if it's possible. So this case we can, only in this case we can talk about consistency of medical records. Okay, and if about to finalize with interoperability, here is given a few common standards, here for 7, CDR architecture of it, and latest fast healthcare interoperability resource here change. Right now, that's present day bar already shifted to right significantly. Again, it's about 3 years old. 3 years old chart, so it's already somewhere when Ashel 7 here already dominate as exchange. So a few points about implementation of EHR adoption, development planning, and some examples will be not provided. Doesn't have enough time. So actually, similar to development of national database, when we are going to implement some information system within our practice, we have to pass some steps like envisioning, evaluating, selecting, implementation, and which of this contain more steps when we have to identify goals, provide assessment for resources, create some detailed plan for implementation, create strategies, and create first of all strategical plans, and develop some detailed steps for implementing this information system. Then evaluate our internal workflow, adopt to usage such system, provide some testing, then perform here is point end user training, because we have to prepare our staff to use new system, going live, and still stabilizing initial house, which will be definitely available, and provide continuously support for our new implementation. So all these steps, so as you can see, it's only at right side we are talking about going live and make some practical thinking. So here is we have a lot of steps before we will be able to pass through. And in fact, it's reason that 80% of work on implementation must be spent on resource change management, and only 20% that's spent on technical issues with technology itself. So I'm totally agree with this assessment, because failures with implementation of various medical EMR system, what I personally have seen, every time they are related to exactly to problem with lack of management, various organizational social issues, etc. Here is like restricting workload, the organization resistance to change, personnel's resistance to design and implement flexibility needs, complex healthcare environment, etc., etc. So both sides have some responsibility and could be blamed for failures, like both staff, medical as well as IT. So sometimes we have, yes, some significant limitation in software, hardware, networking technologies, which made it difficult to double implement in small budget, conscious multi location in case of distribution system in developmental country, in areas where we have very high poverty level, etc. But okay, still dominate if we have some at least minimal resources. So then in that place, organizational issues come up. Okay, so here is about, if we talk about some, that's given information relatively old, about already 10 years, old information about success failure rate. But again, from my observation, things not significantly changed even up to now. About maybe a little bit more success, about 1/3, about 30% mutual success, about 40 projects fully completed, but over budgeted, over scheduled, lack of full scope and finally, maybe even not 50, maybe even up to even much more. That's actually over budget. It's very common case. And up to quarter could be experienced failure or be cancelled. Yes, like pre-war start Ukrainian e-heals at least twice made attempt to create other solution, but they all failed. So, key contribution factor to implement failure reported via lack of planning, clear vision, goals and approach, not aligned with vendor identify, schedules, practices, and priorities and other resource responsibilities, incomplete and clear and unchanging requirements, lack of executive support and commitment, lack of resources dedicated to the project like staff time, money. It's everything, for sure. End user involvement, project management, IT support, and realistic expectations that can be accomplished and how quickly it can occur. So here is that's a combination of these things, like manager I want to everything be automated for minimal budget and like by tomorrow. So I hear such things. For sure, in this case, that such project will fail. And here is given few reference for various documents which provide level of adoption and success and what barriers available and prevent to manage and introduce new medical information systems, and especially EMR medical information systems. So here is like about, it was about 2020. like about 2020. And here is we have privacy and legal questions set up first place, but high startup cost, workflow changes, they are second and third, and then system complexity, etc. Okay, and here is per European Union, a little bit older data about how primary care adoption and compare this to different years. So as you can see, some countries have a good progress in automation, but still even very developed country like French still have significantly incomplete even automation of primary care level. So EHR adoption, like e-prescribing and other services within different European countries, it was again 4 years old already data. Become better, but still not 100%, even across EU. And here is situation for adoption on the United States when we have some certified and basic EHR. Older data still not find more recent information, but still right now, as you can see, situation comes much better and going to be closely to 100% right now. Okay, and here is we have situation for office-based physical health records, again up to 5 years ago, still become more and more it's also United States now much more better and going to be fully automated, even closely to 100%. And if we're talking about finally a few words about developing countries, some issues and active EMR and reporting system which is available for development countries. So here is we have huge amount of problems and issues with development country, like mobile population, limited means patientification, shortage, health workers, limitation access to health services, limited infrastructure, access to drugs, and this combined with poverty, donor and agency requirements, privacy, confidentiality, security issues. So part of this problem Ukraine faces right now with war, when we lost a significant part of its infrastructure due to continuous destruction by Russians. Lost also personnel, and the population mobility increased drastically when people try to flee from war zone and so on. So here is most of this we already faced the same. And what is about talk about basic sampling, few EMR and reporting system used in developed country, developed using different methodologies. So here is we have at least pair of free open source solution, OpenEMR, OpenMRS, relatively popular, and I have experience with both. As I here given a list which is also available for free. Now, in Ukraine, we not adopt any of this because starting point was a bit better, and we already have multiply of commercial EMR solution with flexible, reasonable, and affordable prices, which now interconnected using our e-health. So actually, it's all for today. Thank you for your attention. Goodbye and have a nice day.